So we are on chapter 6. If I remember correctly, what we did was write our own versions of all of these things. Right. And then there was like these weird examples that wouldn't compile for some reason, or they were like sort of skeletons for how you would do things. So I think the first thing we need to do is just create writer Haskell module writer where, and we're going to write a new type writer W. Oh, I should mention, because we're doing this, I actually recognized someone using a reader monad in the wild without actually knowing they were trying to use a reader monad. I was really proud of myself. It was somebody writing Python code, and I was like, oh, you're implementing a reader. And they were like, what's a reader? So I sort of explained it to them. And then we, cleaned it up a little bit to look a little nicer. So I was actually really proud that I was able to figure that out. Or notice that that was the thing. Okay. So this thing, let's see here. So the state monad is internally represented as S2 tuple AS. From that type, reader encodes the passing of information S2, or I'm sorry, reader encodes the passing of information, the S2 part. The other half, AS, is called the writer monad. In contrast to previous expositions, let us first write the monad instance for this type and then discuss its possible usage. First of all, a writer is parameterized by the type of the elements in the first component of the tuple. This means that similar to state SA and reader RA, we actually build computations of the form writer WA. Okay, that's not surprising. In previous sections, we described a high-level view for introducing the version with new type. Good, done. If you lose track of what's going on, you can always ignore the wrapping and unwrapping. That is, forget about the writer used both as a constructor and in matching, and only focus on the tuples. Note that we also reverse the position of W when compared with state, but this is irrelevant. I guess that just means that so you can build like maps over top of it by putting the A over here. Whereas map in like state and reader are just composition. Now, because you only have a tuple, your map would be over the A, I guess is the idea. Or your functor, I should say, not your map. Okay. So now we... Oh, that's a good point. Really good point. We can probably just derive them without even writing them, but for practice, we will write them, because that's what we do. So functor writer W where. So we could do it this way. We could also just pattern match out the tuple and get rid of this. Either way is the same. I sort of prefer looking at it like this. I don't know why. So we're gonna get an A, but we need to generate a W. And how do we generate a W? Well, we could. Where could we get this W? I suppose you can get it from a monoid instance or something. Or it could just have its own applicative instance. Wait, no, you can't do that. It's got to be able to generate a W. Yeah, that's the only way you can get one, right? Like, I was thinking I was crazy, but and then this becomes empty. What is this complaining about? And then oh, good. Okay. Show writer. What? Where did that come from? So we need some way to combine the W's, but it's probably still the fact that it's a monoid. And then oh, something like this. Oh, and then that's the wrong operator. You can see how that's not the right operator. And these parentheses are completely unnecessary, right? Yeah, thought so. So this W is supposed to be a state. But I guess the only way to deal with these is combining them together. Like there's no other way to do this. We're not given a state to modify with a function. Yeah, this is the only way we can do this. Suppose we're probably going to need that for the monad as well, but we'll find out. Return is pure, and then take a monad and bind f. So writer wf. Oh, sorry. WA bind f. And So F will take, that will give me, this is almost right. It's just that I can't get, I need to stick this W into here. Otherwise I can't do anything. I should. So that's probably the cleanest way to do this. Yeah, I can't think of like a nicer way to make this happen. Okay. Says the difficult part in this implementation is that you need to choose a W for any type. But the only way to do that is a monoid, we know that. And then it shows the functor instance, which I actually like our implementation better. There's probably ways to like do some lat stuff here with run writer and maybe write this like without explicitly pattern matching on the writers, but like that doesn't really matter that much. If we really wanted to be cute, you could also write coerce. Oh, that's interesting. Sometimes I forget about coercions. Yeah, and the reason this works is because a tuple is already a functor, right? That's interesting. So actually wait. Patiently. Yeah, you might not even need, well, let's just try it. So fmap equals coerce, and is this the right, I mean, it's got to be the right coerce, right? It doesn't quite like this. Is it because like the error just is like, maybe it will be more obvious if I just do following? Like I might just be like a type, might just be missing an extension or something. So I guess I just need to be more explicit about how this works via the thing you wrote before. Now this is the same thing. because that's just fmap. Do I need to provide the type here? Like this fmap is... Sorry, I'm not super familiar with coercions. I just need to say that this is like A, B, something like this. Oh, this is like... Yeah, I did. Could it match type A to B with tuple? Sorry, I don't know enough about this to... I'm interested in seeing where this goes. Fails in a different way. No, that's okay. I'm guessing that you can probably like derive functor directly, like without any nonsense. Whoa, that's not what I want to do. Like if we just get rid of this and we write here, deriving... Oh my goodness, I can't type functor. And then we get this and delete this. Like this thing can probably just... I can probably just let the compiler do this here. Right, like applicative monad. And comment all of this out. But anyway, that's no fun. It's basically cheating. It's not cheating. I mean, it's unsporting. Yeah, exactly. So we'll comment this out. I keep pressing the wrong key combinations for whatever reason. And then and this. There we go. It's good practice to just do this stuff over and over and over again too. So I'm always happy to do it. I do kind of want to try and write this one with without explicitly matching on writer if possible. I want to see if we can do it. I mean, it's just going to be another let, I think. Wifwa. Is that a fun pronunciation as well? Wifwa. Good. Okay. So it's already a functor. So we could say let... I don't like this. Maybe we can do this. I don't see how we combined this W and W prime without pattern matching. Right? I think we have to pattern match here. excuse me. There's probably some shenanigans with yeah, morally equivalent. I mean, that's kind of, I think that you have to do that though for the first one. Although you have to do that for both of them, and if you do that, like, you might as well just write this. Like, yeah, I guess the closest that you could do is say W prime. No. Yeah, I don't see how you do this cleanly. This is probably better. Honestly, these are probably cleaner anyway. They'll be easier to read for other people. But these monoid instances already exist. No. We're thinking about this incorrectly. We're thinking about this incorrectly. Wifwa is just run writer with run writer wa, isn't it? Oh, and then yeah, so we're just thinking about this slightly incorrectly. But that's why this is so easy to derive, because you can just write both of these like that. And you should be able to do essentially the same thing here. um I shouldn't look at the chat like I'm trying to get an answer. So here, no, I don't think it makes sense here. I think this is the right one, because you need to deconstruct to get W. The only thing you could do is move this to the right and say run writer FA. But again, that one is 100% morally equivalent, which is, I think, what you already said. But in this case, you can do this. That's at least a little nicer, maybe. Is there a way to... No, I think this is fine. I'm thinking too hard for no reason. Okay. Okay, so we can skip all this because we know how to do it. As a final note, every time we use that above mapend or whatever the semigroup operator is called, does this have a name? Do people probably just call it mapend, right? I would assume so. Or mappend, one or the other. We could have chosen to flip the arguments, writing w2, w prime, w, flip those. The choice we make in writer monad is arbitrary, although it is somehow justified by the sequential reading of the bind function. As yet, we have not seen a way to influence the first component of the tuple that makes up the writer monad. The tell operation breaks the barrier. So we can write tell unit to tell. We're going to take something. Nope, this is a dot. For whatever reason, I want to keep writing a $sign there, which is obviously incorrect. Also, I just noticed this and I hate it. And also, I would like to put a space here, please. Thank you. Okay, so I think that's tell. So it's like tell. The names of these always throw me off. Maybe I shouldn't worry about the names. I should just think about the types. Give me a state. I'll give you a writer. I'm not sure what the best way to think about these names is. They always confuse me. The value given as an argument is combined with those produced in the other parts of the writer action using the corresponding monoidal mapend. For example, consider the following piece of code that tells two different numbers under the addition monad. So, where? Who am I? Do tell. Replace with num. Certainly not what I want to do. Where does that come from? Functor. Well, probably supposed to come from monoid or something. I feel like that's not correct. Yeah, it comes in monoid. Or semigroup is probably the same thing, right? Yeah. Is it in both? It looks like it's in both. Monoid under addition. There we go. Oh, it does say num wrappers. But why would it need num? That doesn't really make sense to me. All right. So we're getting a writer sum3 unit. Then we bind with the monoidal operator to get a new b. So this tell gets us b as is another unit and this, and then we return 7, which gives us another writer that just gives us the 7 and the string. It's pure essentially, which is there. Although this is supposed to be a mempty, which is kind of weird. How does this get 7? Well, I guess the better question is, does it get 7? I assume that it does. So T sample oh, I see. I need to run. Oh, that didn't work. I can't I can't pull something out of this, right? That's not possible. Not returning anything. But it is getting 7. How is it getting 7? I don't understand that. Not an editor command. Let me see if we can figure out this real quick, because that's really obnoxious. Config nvim init rgb. Nothing in here that suggests that. Is there something in here? No idea where that comes from. No idea whatsoever. So this is being expanded into a series of binds. Um, this is a writer. Then I need a function that returns a writer. Okay, so this is combining these sums with mempty, which is sum 0. Right. So this gives you basically writer sum 0 7. Sorry, I haven't thought about this in a while, so it's important to think about. And therefore we're just combining this up the stack. Okay. Writing it in this notation didn't really help me. It just made me think about it. That's all, which is good because thinking is important. Okay, cool. Not that that was hard, but again, it's been a little while, so it's important to think about. There we go. So in order to get such a computation running, we do not need to provide any information. However, following the convention in transformers, we provide a runWriter function to obtain the final value. In our implementation, runWriter is just the accessor for the new type. Evaluating runWriter example above produces the value sum 7 7, right? Sum 7 7 in a tuple. The other thing I should do is say, I mean, that's the result of that line. This is the overall result. That's probably fine. Except, I see. This needs to be comma there. There we go. Okay. Logging using writer. The writer monad enables us to build a second return value. Build a second return value for a computation by aggregating small pieces. We cannot access the current value of that part of the computation at any point, though. These two requirements are met for the main use case of writer. Excuse me, producing an error message during a computation. Or, I'm sorry, producing a message log during a computation. For example, consider a simple evaluator of arithmetic expressions. For various reasons, we do not want to fail when a division by 0 is present. Instead, we default to a 0 value. Okay. Already deleted these and then wrote them again, which is fun. So let's do data expr lit float add expr whatever divide okay. I really hate all of these dot dots. They're very annoying. I understand that we're trying to, get through this pretty quickly, but it's a little annoying. Right? And if you get anything in 0, it's just 0, else divide b. Hey, Vic, right? If I remember correctly. I actually have a YouTube video for that. As it turns out, it's my most viewed YouTube video. But it's essentially just on my GitHub. I think I have this editor. There you go. Sorry, I remembered that I had that. So there's my NeoVim setup with like a YouTube thing for setting it up. It's pretty easy on Linux because you just need to install this Haskell IDE engine thing, and then COC. You have to set up this thing called coc.nvim, and then once you have those two things set up, it's actually pretty easy to work with once you have this. Getting Haskell IDE engine to work with other editors, I had a lot of trouble with, but I know a lot of people have had luck with Visual Studio, for example. I think so. Yeah. I'm not sure. Let's look at COC and Vim. Oh wait, I think it's literally called COC and Vim. Yeah. So I have not personally found. Well, it does say Vim 8. Do you have Vim 8? Seems to. Yeah, so if you have Vim greater than 8, you can use this COC and Vim, and this is the best LSP engine and autocompleter that I've found. I can't recommend using this enough. I've had really bad luck with a lot of the other ones, but this one seems to work very well. So yeah, I would highly recommend it. There are node pieces and things like this, but it's worth it at the end. It's a little heavy, but it works for any of these languages. Any language server that you can add to it, it will work with. I actually had it working with Swift and other things as well, so and it basically just worked immediately. Like, I didn't have to think too much. So I'm a big fan of this. Can recommend. Okay, so by doing this, we won't ever know if this error case is like achieved. So the proposed solution is to wrap the entire computation in a writer monad and produce log messages. So let's do that. So we'll say eval prime. Not so important if you know the language, but definitely helps while learning either the language or the code base. I would argue that even my experience, I don't have a ton of experience with Haskell, but being able to go evaluate the types of things has been immensely helpful. Like just being able to do this, sorry, wrong one, this, and know that E is an expert somewhere saves me a lot of time in certain cases. So I probably will use this all the time. I don't personally, right? That's a personal thing. There are some people who can do this a lot better than me, for sure. Yeah, exactly. Yeah. It can be tricky to understand the context, especially with the things we were doing before. So I don't know if you saw any of the thinking with type stuff that we did, but there were cases where if I didn't have, yeah, that's fair. We were doing thinking with types like an hour ago. If I didn't have the diagnostic thing, I don't think I would have ever figured it out. Well, that's not true. Typed helped me out a ton, so. But we're getting there. I feel like we're getting better at Haskell, which is good. I'm very happy about that. It only took almost a year of doing it to get okay at it, but you know, that's fine. I might be doing it like doing my learning in sort of a weird way. All right, so we want to wrap this in a writer, so we're just gonna basically pure n. Yep. Add eg equals pure nope, it's going to be that can't possibly be right. Oh, I think it is right. I just had the wrong eval. Yeah. Yeah. Okay, so applicative syntax. Probably everybody's familiar with this, but I'll just point it out just in case. This thing here is going to return a writer list of string float. Okay. And basically what we want to do is make a plus for the float coming from this writer and a plus for the float coming from this writer. Okay, so the way we do that is we f map this plus onto the first one. So in here we have a function that takes a float and returns a float. So if we have a function that takes a float and returns a float, we can just use our applicative, and then bam, we get what we need. So I like the applicative syntax is just awesome once you realize how it works, and you know, being able to do things like this is really powerful. Okay, so fine. By the way, the reason I'm using EG is just I'm thinking expression, and then you know, oh, you know what? F comes after E, so it would probably make more sense if I wrote EF, not EG, but whatever. That's hilarious. Okay, so now we are going to operate. We might be able to do this with applicative as well, but let's write it in do and go from there. So we're going to get like B. L. Okay, so let's see here. So we can't do something really nice like this. We do need the monad to deal with this part. But is there a way? There's gotta be a way to fall through. I don't know exactly how to do it, but I feel like there's gotta be a way to write something like, slash here instead of plus, and then fall out if we have a problem. We could probably just write a function, but this function has no idea of this monadic context. So maybe you do need the monad here. Maybe there's no way to do it otherwise. Also, why? Oh, they're using X. So we can just put X here. There's somehow a cleaner way to do this. Maybe. Can I do the following? I have no idea if I can do this, by the way. I'm just trying it because why not? Oh, do you I forget how this works exactly. Well, what? Weird. You just start matching. Okay. So don't even do this. Just try to match. What are you doing? Um why am I being stupid? We basically need a lambda that takes two functions, but the only way I can pattern match on it. Yeah, I don't think this is gonna work. I'm giving up on this because it feels weird and wrong. I need a function that takes two. What is this complaining about now? Oh, that's what it's complaining about. There we go. Anyway, this looks fine. Just seems like I could probably write it in a nicer way. I just don't know how. I don't want to go there. Time is it? Okay, we're almost out of time, but I'll try and do this last little section here. Okay, so it says be aware, Writer only provides very basic logging capabilities. If you need a framework for logging for real applications, we recommend instead that you look at Fast Logger or Monad Logger in Haskell, or one of the many logging frameworks for the JVM. If it's not clear what I'm doing, by the way, I think it's clear probably to everyone by now. We're working through this book now, Book of Monads, and so it's a book written for both Haskell and Scala primarily. There are mentions of other languages in the book, but just so that's clear. Okay. So other primitive operations. The core of the writer monad is its tell operation. In addition, the implementations available for both Haskell and Scala contain other methods. The transformer library, which implements most monads in Haskell, does not provide an operation to reflect on the current value of writer. On the other hand, it does allow us to run the subcomputation and then look at the result. So I feel like we should just go look at. Let's just go look at Transformers writer. Oh, here, please. Just noticed that it's filling in this as I type. It's kind of fun. Okay, so sensor is one that it suggests. And it looks to me like sensor is all it's doing is replacing the W. So it's, well, not it's replacing the W. It's changing the W. So given an F that modifies this W to another W, just apply it to a writer. Okay, so that's okay. I can handle that. Pass. Interesting. So pass takes a writer with a basically a nested tuple. It must apply this F to this W to produce a new W and an A. The A doesn't change, obviously. Okay. Then we got some other functions. Listen and listens. Interesting. That's kind of all it's saying is that those exist. So I'll keep going. I thought that was going to be a little more involved, but apparently not. So this just says all at once, the RWS monad. Keeping a state while having some configuration lying around. Keeping a state, having some, and producing logging output while running describes a great majority of applications. In chapter 11, we describe a general procedure for combining several monads, monad transformers, but given the pervasiveness of that use case, many libraries, including transformers and cats, provide a combined reader-writer state monad in its own type. The interface of the RWS monad is just the aggregation of the interfaces for reader, writer, and state. In addition, it provides 3 functions to embed computations from each of the monads that make up the mix. So you can take, okay, let me just go find these. RWS. Then it's going to take me here. Fine. Yeah, so the reader operation just takes a reader and embeds it in RW, the RWS monad. What's asks look like? Oh, okay. I see. So there's the reader is asks. Okay, interesting. So this has got listen, pass, sensor just embedded in this RWS monad, and then the state is the same thing. Okay, neat, kind of cool. So I think the end of this chapter is just sort of pointing out a bunch of functions, but I think that with this, yeah, with this, I'm going to call it a night. The next things that we're going to do are bi, contra, and profunctors. So that's the next section that we're going to do. And then we'll we'll finish this chapter and then move on to the next chapter, which is called Failure and Logic. And that will happen next Tuesday. And then after we finish this book, how many pages are left? 83 to... There's about 200 pages left, give or take. So we'll probably be able to finish that relatively quick. And then we'll move on to another book. So some ideas for the other books, by the way.